In this video, I will be talking about the simple vector operations. I will be explaining topics, what is the point, what is the vector, how to apply the vector to create the movement, and all of this basic stuff explained on a practical example. We have this nice Cartesian space grid, so it will be easier for you to explain or to understand the concepts. Let's get into this video. To get the starting project, go to description of the video. Click Get a Project. Download and unzip the file. Open Unity Hub. Click Add Project and select the unzip folder. Open it. In the project view, select Scenes. Double-click Sample Scene. Now you are ready for the video. Hopefully your projects are ready. You should see this view where we have one red cube in the middle, and on the ground we have this Cartesian space, this plane representing 2D space. It will be easier for us to explain the topics of the vectors when you will see the actual coordinates on the ground. Okay, so we are going to talk about vectors, particularly in game engines, in the Unity. We can talk about 2D space or 3D space. 2D space is a space you can see here on the ground. You have just only basically two coordinates, two axes. It's a flat space where we can move only on these two axes. We don't have any height to it, all right? If we would talk about a 3D space, we would have to add one more coordinate, all right? And of course we have it in Unity because we are working with a 3D, so we have this one more axis, okay, representing this third coordinate. In Unity, this axis is called y-axis, representing the height. Then you have this axis. This axis is called z, all right, and this one is called x. Okay, z represents forward and backward direction. X represent right and the left direction, and y represents up and down or height. Okay, so that's the coordinates we have in Unity, and this would be called 3D space. What we have on the ground, we have only two axes, you see, only z and the x. This is a 2D space. Okay, so I think that should be already clear to you. Okay, and what we are going to do now, we are going to explain some topics with the vectors. So let's click on the cube on the left-hand side in the hierarchy, select the cube, and if you don't have attached vector script, you should have the vector script attached to the cube, so you are going to attach it. So I will just remove mine. So we'll start the same. We'll create here add component, and we'll search here for vectors, and you will attach the vector script. Now you are going to open this in your coding editor. So these three dots on the right side, you will click edit script, and this should open your coding editor. If you don't see anything opening, just go up here into Unity and settings, and search here for external tools, and here an external editor, script editor, you should choose here your editor, preferably Visual Studio Code, as you see here. If you don't see it here, you need to click here browse, and you need to find the executable file of your coding editor. Okay, so when I will click here these three dots, this should open my coding editor. So edit script or open script, and actually it's here. And here I have my vector script. This will be very basic video, as I mentioned before. So if you are already familiar with these topics, you can maybe watch the part 2 of this video. As you see here, I'm getting offered here some code. The Copilot offers this to me. I'm going to disable the Copilot for this video. Okay, so first let's talk about the points. What is the point? Let's create here a public variable like this of type of vector3. We'll be working with a vectors3, so with the 3 coordinates, and we'll call this a variable spawn point. Okay, so just simply write here spawn point like this, and we can initialize it to some values. So let's say vector3, and we can initialize it to values, let's say 3, 0.5, and 3, like this. This should be a new vector3. Okay, so this is the spawn point. So it has this coordinate. So let's take a look at our Cartesian space here when we will go back to Unity. So first part of this vector3, so we wrote here vector 3, right? And we wrote there 3 0.5, and 3. So where it should be located in 3D space. So as I told you, this first part here is the x-axis, the second part is y-axis, and the third part is z-axis. So when you will look here in this Cartesian space, when you will now locate the x of 3, it's here, that's 3, right? There's x, y is 3, so now we connect these together, and that's the point you're looking for. Okay, of course, you have also 0.5 for y, and y is this axis which is will be difficult to now look for, like this, and you have some height also to it, so there is also, of course, some height, 0.5, so the point will be here. So basically we'll get this, when I want to move my player, my cube from here to here, it will get to this point here. Okay, so that will be the location where it will be moved. Okay, in a 3D, into this space, very simple to imagine, because we see it directly here. We see this. We see these locations here, 3 and 3, and that's where we want to move our player. Okay, I'll remove this part here, and when you will take look at the player here, the cube, I have assigned to the cube y of 0.5. Why I assigned 0.5? It's not directly touching the ground, as you see here, because the origin point of the cube is in the middle of the cube. You see here, this is the middle of the cube, and this point is attached to this coordinate 0.5. So when I will move it to 0, the cube will be only halfway to the plane, because you see that the point is in the middle. So that's why the half of the cube is down here, so I need to move it a little bit up. If you don't see this axis on the cube, you need to go to the left hand side, and you have this hand sign, you have this move tool and other tools. You go with the move tool, and then you can see this axis here. So that's why actually the proper coordinate should be 0.25. You can see that now it's exactly on the plane, this cube. Okay, so because as I mentioned, this point is in the middle, that's why we have added some height to it, 0.25, because if the point would be on the bottom of the cube, then we could go with a 0, but since the origin point of the cube is in the middle, then we need to go with a 0.25. No, but now let's try, we want to move this cube here to the point 3 and 3. All right? Okay, so let's go back to the code here and actually move it to the 3 and 0.25. 3. How can we do it? We will use a start script, because the start script is called initially as you will run your game. This is the initial thing that's getting called, and we can move our cube to this point 3, 25, 3. Here, since the vector script, this vectors is attached to the cube game object here, we can access the game object, transform, and position. This transform position, what we are accessing basically here is this transform component attached here, this transform here, and we are accessing the position here, these coordinates here, and you can see that currently there are 0, 20, 0, 25, and 0, and we want to change them. So what we will do here, we will say transform position will be our spawn point. Now we will override the transform position, and transform position will become these coordinates here, 3, 0, 25, and 3. Okay, then I will save this file, and I will get back to Unity, and I will run my game, because we need to run the game to execute the code. So this triangle sign up here, you will see the cube immediately moves to this location. When I will select the cube now, in the hierarchy on the left side, you see this location, this position here changed to 3, 0.5, and 3. You see it's 0.5. When you will stop the game, you will see in the right side in the hierarchy, I'll just move the vector script up here so you can see it easier. The spawn point location is stayed as I initialize it initially, so I need to change it to the 0.25 here, 0.25, and now when I will play the game, the location of the cube will be, I'll select the cube, it will be 3, 0.25, and 3. So now it's correct. So we move there. So that's a point. The point represents only the position in the space here. Okay, that's nothing more. There's a somewhere position, a specified position in the space. That's the point. Also represented as the vector 3. In the games, we are talking about the points, but also we are talking about vectors. And vector is not just a point or location in the space. Vector has a direction and also magnitude. And you would use vectors if you would like to express a movement. Okay, so what can be vector? For example, what is the vector, let's say 3, 3? Okay, so I will just make 2D vector. Let's say I've got here vector 2D, which is vector 2. And vector 2 will have this. X part or X component will be 3 and Y component will be 3. So here on our axis, the vector 3, 3 would be this. Okay? And now, this vector 3, 3, we would apply to the origin point, which is 0 here of our coordinate system, 0, 0, where the red cube is, right? So what would be the direction and magnitude of this vector? So you can see the direction is this arrow here. That's where this is pointing from the origin. That's the direction. And magnitude is the size of this line. Okay, so length of this line. So vector, for example, vector 6, 2, this vector 6, 2 here. The direction of this vector would be this, where the arrow points, and the magnitude would be the length of this arrow. Okay, that would be the vectors that are thinking them of like from that they are originating from the origin of our coordinate system from the point 0, 0. But origin of our vector can be also any object in the game. So for example, if I will move my player somewhere else in the game, let's say I will move the player to position 3, 3. And I will be talking now about, let's say, vector 2, 2 relatively to the point where my player is. So let's imagine vector 2, 2 applied to my from the origin of my player. So vector 2, 2 would be on the x 2 and on the y, or we can, this is actually z axis, but we can talk about it as a y, doesn't really matter now, is 2 here. So 2 up, to right, and where they meet is this point. So this is the vector 2, 2 relatively to the origin of the player, and this is the vector. This one here. This here. The arrow describes the direction, and the size of this line, the length of this line, is the magnitude. If I would be talking about vector 4, 4, so 4, 4 would be here, right? I'll use a different color, that will be 4, 4 vector. Okay, so if I would apply this vector to my player position, the player would be moving in the direction of this arrow, and the size of the step of the movement would be larger than this one here. The larger vector, the larger is the movement. Okay, so the points are just the location in the space, but the vectors, they have direction and also magnitude, size. And the best way would be to actually see an example. Let's revert this and move the player back as it was on the location 0, 0 here. Now we are going back to coding editor and we are going to create a new vector tree. Okay, we'll call it, let's say, direction. And let's say direction will be the new vector tree, and the direction will be 1, 0, 0. And now we'll create here update function, void update. Update function is called on every frame. As you will start running your game, every frame update function will be called. And what we are going to do here, we'll access our transform position, so the current location of the player, plus equal, and we will increment, we will add to this position our direction. So like this. But you will do it this way. Update function is called 60 times, roughly 60 times per second. If you have 60 FPS, 60 frames per second, then update will be called 60 times per second. This will create very crazy fast movement. So when you will run the game now, you will see the player will just simply run out of the map immediately. It's away. So what you will do in the game engines, you will multiply it by time and delta time, because this is the time how long the one frame takes. This is a very small number, and multiplying it by the direction, this will lower it. So it will express the movement as it should be in 1 second. So just if you have directions and you are applying the movements, rotations, and whatever, you're always multiplying with the time, delta time. But that's not about in this lecture. Okay, so we are applying this direction. So what should happen here? Okay, let's go back here and wait until it's recompiled. So what we are doing, we are applying this vector 1, 0, 0. So we have y and the z is 0. Only we are applying the x. So we are getting our player position plus applying this vector. So what is the vector 1, 0? So there is this vector here, right? This one here. That's the direction, and that's the magnitude. So I should move 1 unit per second. And you will see it when it will be now. I will just remove this from the screen. When you will play your game now, played now, you will see your player will be moving right side. Actually, it's moving to the right side, but the spawn point it's also applied. So if you want to don't apply any spawn point, just go back here and transform position, just comment it out like this. Let's get it back here. Or we could also do it through the script. We could extend the spawn point to location 0, 0, but doesn't really matter. Let's play the game, and you will see it will be moving 1 unit per second. Okay? 4, 5, 6, 7. If I would increase this vector, so it would be not 1, 0, 0, but 2, 0, 0. So the vector would be here, right? Here. The direction is the same. 2, 0, 0 is the same as the 1, 0, 0 direction. But you see the magnitude, the size of this vector, the length of it is it's bigger, twice as big. So we'll be moving now faster. So when I will change this here, direction in a script on the right side. So look at the right side when you select a cube. On the vectors, as you have a direction here, change it to the 2, 0, 0 and play the game now. And you will see we'll be moving 2 units per second. 2, 4, 6, and you're going much faster. So the larger vector, the larger magnitude is, the bigger is movement, as you can see it here. And we can change these vectors. So let's say when I will go with a vector direction 2, y I will leave 0, and z will be 2. So now I will be moving, what will be my vector? My vector will be 2, 2. So this is here, right? 2, 2, and this is the magnitude and direction. This direction magnitude is this length of this arrow. So now I'll be moving diagonally. Right? When I will play the game, I'll be moving diagonally here. Okay, and I can adjust it as I want. If I want, I can make the direction also 2, and I will now be moving also, it will go also high. I'll go also this in the third direction. So you can see now we are going flying away. Okay, we can stop the game now. Okay, but let's leave the direction to be as we have it before. So 2, 0, 2. Now let's try to go with the really big direction or big vector. So let's set direction to not 2, 0, 2, but 8, 0, 8. So now the vector is really large. So 8, 8. If you imagine here, it's like a really big vector. So 8, 8 is here, right? So 8, 8 is this point here. So this point here, and the magnitude and direction. So direction is, I cannot really write a straight line. This is the direction. The magnitude is the size of this line. So now when I will play the game, the movement will be really quick. So when you play this, now you'll see the movement is very quick. In the movements and vectors, there is a concept called normalization. And normalization is simply reducing the magnitude to the value of 1. So if you have a vector, the magnitude is larger than 1. So for example, this vector here, it will be easily explained on one axis. So vector 4, 0. So this vector here. So this will be just simply this vector here. We can immediately tell the size of this vector. So we can see the size is just the size of the line. So what is the size? The size is 4. Simply as that. That's the magnitude for 4 units. And normalization is a process where you will remain the direction of the vector, but you will reduce the magnitude. So behind the scenes, when you will apply the normalization function, the direction will stay the same, but the magnitude is reduced to 1. So here. So this will be your new vector when you will apply the normalization. Simply, magnitude will be reduced to 1. Okay? Same if you would have a, like, let's say magnitude here, or a vector 2, 2. So this vector here, that is a vector 2, 2, and you will apply normalization. You simply reduce its magnitude. So the magnitude here is larger than 2 here. So then if you would apply normalization function, it will normalize it somewhere here, because the length of the vector here is 1. Okay, so that's the normalization process. We can see it I will show you now. It doesn't matter what size I will use my vector here, direction. It doesn't matter what's the magnitude of the vector. I can apply it here normalized like this, and this will reduce the magnitude to 1. So now my vector will be always moving 1 unit per second. So when I will play the game, I went last time very quickly. Now I'm going only 1 unit per second. You see, that's the normalization. That's another concept you should know. Okay, so now let's talk about how to move player towards the target. I will create a target here. So as you have this cube here on the scene, just select it and click Ctrl D or right click here and duplicate. All right, now you have a duplication, but it's on the same location as your original cube. So just move it a little bit outside and call it enemy cube. So just select it, click inside and call it enemy_cube. I'm going to change the colors. I'm going to the project. I'll go to materials, and in the materials I'll create a new material. Right click, new material, and call it green. In the right side, as you have a main maps, here the color is white, select some bright green, and drag the color on your player. So this will be player, which is on the location 0, 0. And this will be enemy cube. Select the enemy cube one more time, and as you have this vectors script here, please remove it from the enemy cube remove component. And now just place the cube anywhere in the space. Doesn't really matter where you will place it in the space. Let's say here. Now, when I want to follow the cube, what I need to do? Let's go back here. These parts here we can actually, we don't need them anymore. I can comment them out, or we can leave it. If you want to, you can leave them. I will comment out also this, and I will create here a new public variable with the transform type, and I will call it enemy, like this. And this way I will get the enemy position. Now just go back to your game. And as you have here your player cube, so click on the cube here. And you see the vectors. There is a non-transform. Just drag your enemy into it. Not enemy, but the enemy cube actually. So select one more time your green cube and enemy cube, drag into the enemy here. So now this will get you the position of the enemy. So when you will select the enemy cube, what's the position of the enemy? You can see it in the positions transform. It's a 8.22, 0.25, and 5.66. What I need to do in order to move my player in the direction of the enemy, what I need to do? When you will go here, the maybe most obvious thing for you would be just get the player position. So the transform position is my player position, and increment it by enemy position, right? So I will access enemy position, and also I will multiply it by the time delta time, so it's moving slower. Okay, so that would be maybe the way how you would think of it. When you will play the game now, you will see indeed the player is moving towards the enemy. So that's, yeah, it's working, but it will stop working. We can also normalize the enemy position, so it will be not moving so quickly. We will normalize. Now you will normalize the vector to 1, 1. So when you will play now, select now the scene view. Go to the scene view, not in the game, but the scene like this. And now you can move the cube. So just select the cube and start moving it around. You can see as soon as you will start moving the cube around, the player is not really following the direction of the cube. Okay? So what's basically is happening now, I will show you one more time. I will stop this. Player will start moving towards the enemy because there is some location of the enemy, and that's the direction the enemy is. That's the direction to the enemy, basically. That's a vector that enemy has, that the position 8.22, 0.25, and 5.66. This is this vector if you will think about it from origin 0, 0. But if the enemy will move, let's say here, all right, my new vector will be this vector here, if you will think about it as the from origin point, because we are always thinking of the points like they are beginning from the origin point. So this will be my new vector. So basically when my player moved here somewhere, my player is currently here, let's say there is my player, and my enemy moved here. So the new vector is this. This is the new vector, so my player will be moving up direction. Okay? So one more time. If I'm thinking of the point as the direction, so this one here. Okay, I'll draw it here. So that's the point. Okay, if I'm thinking of the point as the direction vector, my player is moving initially correctly. It will remain this direction. But if my enemy will move from here, let's say here, and this will be the new location of the enemy, then the new vector originated from the 0, 0 will be this vector here. Okay, and if my player is already here and my enemy moved here, I will start applying this vector to this position here. So I will go just simply up. I will not go here. So how to actually move towards the enemy, towards the target? To move towards the target, you need to just simply get the position where you want to move, and you need to subtract it by your position. So let's explain it here. Let's say if you want to move, let's say our player is here on the 1, 1. Let's select the cube, move it to the x1, z1, or x2 and z0. So the player is here, and I want to move the player to location 8, 0. So here, 8, 0. What I want to do is to get this target position and subtract it by my player position. So I would have to do this 8, 0 minus my player position, which is 2, 0. So subtraction works like this. You will get one component subtracted by other component from one vector to the other vector. Now one component from first vector minus component from the second vector, by y component from second vector. So what's the result? 8 minus 2 is 6, and 0 minus 0 is 0. So that's the vector I want to apply to the player movement. Okay, 6, 0. That's the direction I would like to move. Okay, so this will create this direction. Okay, and when the player will be already at the 8, 0 now, let's say the player will be at the 8, 0. So player will be here. Okay, at the 8, 0. But in meantime, my enemy will move here. Let's say we'll choose something easy to calculate. So 3, 3. So my enemy is here already at 3, 3. I will do the same thing. I will get the target position, so 3, 3, and I will subtract it by my position here of player. So I would go with the 3, 3 minus 8, 0, and I will get a 3 minus 8. So this will be a minus 5, and 3 minus 0, and this is a 3. So that's my new vector. That's the new direction I would like to move. So from this position of the player, I need to move 5 units to the x. So minus 5 units is here. This here, 3. And 3 units up is here. So that's the new vector. Like this. And that's the magnitude of the vector is the size of the line. So you can see the magnitude of the vector is it's always changing depending of how far I am from the enemy. And that's why you would use the normalization. So I would get this vector here, and I would apply the normalization, and that would maintain the direction, but it would reduce magnitude. So magnitude would be here, like this. That would be the new vector, where the magnitude would be 1 from here, but the direction would stay the same. So that's how you're applying the directions. Just get a target minus your position, and that's your direction. We can try it now. Okay, so let's go here. We can comment this out. So we'll do it like this. We will get here var direction. So my enemy position minus my position, like this, and that's the direction. And now there's a transform position plus equal direction and multiplied by the time, delta time, like this. And you will save this now. You will see that when you will play the game, your player will start moving towards the enemy. And it's going first faster and then slower. And why it's that, I explained to you. Go to the scene view, click on your enemy cube, and you can move it around like this. You can see faster away, the further it is from the player faster moves, and when it's going towards the enemy, it's slowing down because the magnitude of the direction is changing. If you want to keep the movement regardless of the distance from the enemy, just simply change the direction to normalized, which maintains the direction but change the magnitude to 1. And now you would always go with the same movements. When I'll play the game, I'll go back to the scene view and I will start dragging my enemy around. You can see my player will always move towards the enemy, and it's maintaining the speed of the movement. Okay, so that's the follow functionality. Just get a target, subtract it by your position, and you have a direction you can apply to the player, and the player will be following the enemy. Okay, the next concept is scaling of the vector. So if I have this normalized vector, okay, how can I make the faster movement? Then simply I would apply multiplication. So if you have a vector, let's say your vector is 0.89 and 0.65, how to increase it? Just multiply it by the scalar number. Scalar number is a simple number, let's say by 10. If you multiply it by the 10, then your vector will be 8.9 and 6.5, and that's your new vector, which is much larger than the previous one, and this will apply the faster movement. So if I want to move that faster, I would create a variable. Let's say you can do it up here, create a public variable, public float. I would call it speed. I will assign to the 2. And then I simply will get my direction normalized, and I will multiply it by the speed, and this will just increase the movement of the player. Now when you will go back, play the game, your player will be moving much faster towards the enemy. Okay? And you can increase the speed, so I will go and select the cube, and I will increase the speed to 5, let's say. Now the movement will be even faster. You see? So before we'll go to another concept, I would like to also for you to see the difference between applying the direction and applying the enemy position. So what we are going to do, let's go back to our code for a second. I will create here a global variable, private, and I will call it, will be type of vector3, and it will be enemy direction, or direction to enemy. Direction to enemy, like this. And here, as we are computing this direction, I will comment it out, so we have it wrongly as before. And I will get the direction to enemy will be simply my enemy position. So that's the example we had before, right? So the enemy position. And I will be applying the direction to enemy this way. Because that's wrong. I told you you cannot just move towards the enemy just by adding the enemy positions to the player position. This will simply not work. We saw already the example of this. The player will just maintain its direction like this. So we'll play the game, and I will. Okay, this is too fast. Even let's maybe we can decrease it. Just divide it by 2, let's say. So it's slower. I want to show just an example of this. And select the enemy and start moving the enemy cube. You see the player is not moving towards the enemy. See, it's going completely off. Why it's going off, I will show you. So we'll go with this function on draw gizmos, so we can actually see something draw on the screen, and we will draw this. I will write here first gizmos. You don't need to know this part, but I just want to show you how you can imagine this. Gizmos, draw, we'll go with the draw sphere. Okay, I'll get a transform position plus enemy, or direction to enemy like this, and with 0.1 on the size of the sphere. Okay, and direction to enemy, this is still, maybe it's moving too quickly. I'll just keep it as it was originally. I don't want to confuse things here. So let me play this. I'll stop the game immediately, stop it, and select the player. And actually we should normalize this first because it's not normalized. Let's go back here and normalize enemy direction. Okay, and do it this way. So if you are applying the only enemy position to the player position, this is what will happen. We'll play the game, stop it immediately, and go to the scene view, and you can see this cube, this sphere, this red sphere, represents the player direction. And you can see the player direction is initially showing correctly. It's showing towards the enemy. But as soon as I will select the enemy cube and I will start moving it around, let's play the game, you can see, you can play a little bit, you can see, now this cube adjusts, it's adjusted here, but that's not where is the enemy. The cube is adjusted to this here. You can see whenever is enemy relative to the origin point. So here. Okay, and you can see this represents this here, this direction. So that's what we have applied before when we have been incrementing the player position by the enemy position. And if I will move the enemy, let's say, look at the enemy, we'll move it enemy here. I'll play it now, so I'll just click this arrow step. So now, again, it's not pointing exactly to the enemy, but it's pointing from the origin point here, enemy, and this direction is applied here. Okay, so that's what will happen when you are applying the enemy position. Let's try it one more time. Let's go with the enemy wheel. Let's place the enemy here, like this. Let's say here, or up here, like this. And you see, again, this sphere adjusted, but not to the where the enemy is, but enemy relatively from the zero point is this is the direction where it's from origin point, and this is exactly applied the same here. So that's why you cannot just simply increment the transform position by the enemy position, because this will apply in the direction of where the enemy is regarding the point 0, 0, the origin point of our grid. So that's what you need to do in this case. You need to get the target position minus the player position or your position, and that's the direction. That's the vector you will be applying to the player. So now we can see the good example where we can simply remove, and this direction here will change for the direction to enemy. And now we will save this and we will play it. So now you should see that this will be applying correctly. Go to the scene view. Did we normalize it? No, I didn't normalize it. My mistake. Let's normalize it. Let's just simply wrap it in the brackets like this and click here. Right here, normalized. Save this. So you'll be changing magnitude to 1, so the movement will be always the same. Let's play the game. And now go to the scene view. And you can see when it will be moving, the enemy, you can see the sphere is always pointing towards the enemy. Okay, because I am subtracting the enemy position minus player position, and this is giving me the correct vector, direction vector. Okay, so that's something you can just visually now imagine. Okay, so we have covered points, vectors, multiplying vectors by scalar. So if you have a direction, you can multiply by the speed, let's say, as we have explained here, by speed. This will increase the magnitude, so it will be moving faster. Then we have explained the directions, why we should not apply the target position, but rather compute the direction by subtracting. Okay, and now we will talk about the distances. So how can we get the distance towards the enemy? To get a distance is very simple. We can use what we have already used, that's a subtraction. So if my player is as it is at the 0, 2, as you see here on the grid, okay, and the enemy is here, let's say on the 6, 0. So here is the enemy. So the distance is basically the magnitude of the differences between their positions. So I would get the player position, which is 2, 0 right here. This is a 6, 0. So again, I would go other way around. So I would go the enemy position minus my position. So the enemy position is 6, 0. 6, 0 minus 2, 0. This will get me the vector. So this will get me 4, 0. 6 minus 2 is 4. 0 minus 0 is 0. So this will get me 4, 0. So that's the basically vector here. 4, 0. And the magnitude of this vector, so the size of this vector is the length of this line is my distance from the enemy. Okay. So to get a distance, you will just simply go like this. You have a direction to enemy, but you're normalizing it here. But so because we are normalizing it here, we are reducing the magnitude to 1. So this will not get me the right direction. So I will just do it differently. I'll do it like this. Var, and I'll call it distance. You would get enemy position minus my position, transform position. Okay, I'll wrap it in the brackets, and you will access the magnitude, and that's basically the distance. So when I will write here debug log and distance, this will get you distance. Okay, so when you will play this now, go to the scene view. I'll just zoom it in and go to console. And as we'll start moving the enemy further, you can see the distance is larger. As my player is approaching the enemy, the distance is decreasing. So that's a distance. Just again, use the subtraction, get your target position minus your position, and access the magnitude, and that's your distance. Okay, because you see when my player moves over very close, it cannot really find the ending position because the ending position is changing, and so it's oscillating on the spot because it's always trying to move, even though it's reached the target. So what we can do in such a case is we can use a distance. So as we are doing this, we are doing two similar operations here, which is not that great. We should simply go with the direction like this. All right, actually, you don't need to now visually represent this anymore. So this direction to enemy we don't really need. On draw gizmos we don't need as well. So what we can go with here, which will be just simply var and direction, which is my enemy position minus transform position, and distance is simply direction and magnitude. Okay, and this direction we can apply here, but don't forget to normalize it. So direction normalized and multiply it by speed. Okay, so here you have a distance, nothing changed here, but what you can do here before you will start moving any further, you can check if the distance is, let's say, smaller than some threshold, let's say 0.1 units, and if the direction is smaller than 0.1, or actually distance, not direction, but distance is smaller than 0.1, then you can simply return and you will not move anymore. Okay, so we'll save it this way. You'll go back here, and now when you will play the game, you can see the player will move towards the enemy, and it's not oscillating, it's just simply staying there. Again, if I will move it, like this, okay, and we can even increase the distance. Let's say it will stay like 2 units from the enemy. Okay, and we will do this. We'll play the game. It will be staying 2 units from the enemy. You can see it will not move any further. With here, it's always staying 2 units from the enemy. Okay, so that's the distance. And the last topic I want to talk about for this video will be dot product, which is also quite important in game development. So I will actually comment out everything from here for now. So the update will be not doing anything. And we'll be talking about the dot product. So with the dot product, you can actually tell where is your player relatively to the target. Okay, I think actually first I will write the operation here, how to use the dot product. So let's write here this float dot product. Dot product is not vector, but the dot product is just simply scalar value, so normal value. And we can do it like this. Vector 3, you can access vector 3 and a dot all right? And you will get your enemy forward direction and direction to player. Okay, let me get your player direction. So player direction will be my we need to get a direction to player, so let's do it like this: var and direction to player. Direction to player. And this direction will be direction from the enemy towards the player, so the other way around. So how it's the direction from the enemy to the player? So that would be just simply the other way around. So my direction, my position, transform position minus enemy position, and I would normalize it. So that will be my direction to the player from the enemy perspective, and I would get this dot product of enemy forward and direction to the player, and this will get you debug log, and this will get you dot product. So I'll write here dot product. Okay, so what's the actually enemy forward direction? Let's first examine this. So when you will select the enemy cube, enemy forward direction is whenever this we'll put the global, whenever this blue line is pointing. That's the forward direction. So basically where the cube is facing. Okay, it's this blue axis. That's the forward direction. So the forward direction of my cube here would be vector where the x, y is a 0 and z is 1. So it will be in the vector 3, it will be 0, 0, and 1 because x, y, and z. That's the forward direction for the enemy. Okay, where this blue cube with this blue arrow is pointing. If I want to rotate the enemy, this direction of course changes. But first, as you see here up here in this panel, you have a global direction selected. You want to change them to local ones, like this, local. And now select the enemy cube and rotate the y-axis like this. Just increase or decrease y, and you see this blue line is pointing differently. So let's do it. Let's change it to 180 degrees, and you can see now you can imagine the cube is pointing whenever this blue arrow is pointing. That's your forward direction. Okay, so I will get this vector of whenever this blue line is pointing. Then I will get my player. So I'll select this cube here, and I have here this blue line where the player is pointing here. And what I'm doing here is a direction to player. So that's my transform position here of my enemy. Here's my player position. So I'm getting the player position minus enemy position, and this is getting me this vector here. So direction to the player from enemy perspective. I'm getting this vector and computing the dot product of this vector and forward direction of the enemy. Okay? So the forward direction is where this blue axis is pointing. When you will select the enemy, actually, I will select the enemy cube. So I will just use the better angles so you will see it actually better. Like this. I will move my player a little bit to the right side. So my cube or left side like this. So one more time. We are doing the dot product between the forward direction of the enemy, which is here, like this, and direction of the player. So direction of the player is here, like this. We have these two vectors with some values, and we are using the dot product. What's the dot product? It's simply multiplication of the vectors to get a scalar value. So we have these two vectors, and we are going to multiply them. So you can imagine this. If your vectors are I will go with the simple numbers. If your vectors are, let's say, 2 and 3, and you will use the dot product, let's say this dot here, with the vector 1 and 2, the dot product will be this equal of multiplication of this part and this part plus multiplication of this part and this part here. So this would be 2 multiplied by the 1 plus 3 multiplied by 2. That's the dot product, and this will get you number 2 plus 6 is so 2 plus 6, and this is 8. So this will get you the value 8. What you would also do here, before you would do the dot product in Unity, you would normalize these values. So these values would always add up to value 1, and this will get you the lower value. But this is basically dot product, what you see here. And you can do really interesting things with this. So when I'm doing here this dot product, let's keep here, this debug log of the dot product, let's keep it here. And play the game. All right, you can go to the scene view, and now let's move your player. You can see how the dot product is changing. It's 1 here, this is lower value, and here is lower value. So basically when the value is larger than 0, the player is in front of the enemy. Okay, you can see if the dot product is positive value, the player is in front of the enemy. When the player will move behind the enemy, the value is negative. So you can see with the dot product, you can tell whenever the player is. So negative value is behind the enemy, positive value is in front of the enemy, and if the value is 0, close to 0 like this, here 0, is perpendicular to the enemy. Okay, 0, also here will be close to 0, it's a perpendicular, behind minus values, and positive values is in front of the enemy. And that's the dot product, and usually that's how you would apply it if you would like to get this detection here. So you would get a direction to the player, so from the enemy perspective. So transform position minus enemy position, you will normalize it before, and then you will get the dot product of the enemy whenever the enemy is facing the forward direction of the enemy, dot product of the direction of the player, and this will get you basically the value which can tell you if the player is in the front of the enemy, if the player is in the behind the enemy, or on the perpendicular to the enemy if the value is 0. So here you have some basic operations with the vectors, magnitudes, directions, vectors, points in the space. Hopefully it's getting much more understandable after this video, and I will be covering some of the base topics later in some of my other videos, so you can watch them there. So that's gonna be from this one, and see you around. Cheers.